Distribution through brackets. What does this mean? Well, if you start with something that says xy to the power of m, that means that each part in your brackets, so your x in your brackets and your y in your brackets, both get raised to this power of m. So over here you have an m, and over here you have an m. In words, an exponent outside brackets applies to each part within the brackets, including coefficients. So we have a coefficient in this example here of 4. 4xy to the power of m. The m is applied to everything. I get 4 to the m, x to the m, y to the m. Using actual numbers, I have 4xy squared is equal to 4 squared x squared y squared. And then I simplify that 4 squared to be 16 x squared y squared. 3z squared all to the power of 3. Now, in this case, the 3 is raised to the 3, and the 2 is times the 3. That's the law that we learned before. An expanded form, we got this in class from a student. This was 3 times 3 times 3 times z 6 times. These z's here that I'm talking about can be written as z squared. 2z's is z squared. This is how many different ways you can write it. Really, over here, 3z squared cubed means 3z squared, 3z squared, 3z squared, multiplied by itself 3 times. In expanded form, again, and then in simplified form. The 27, where does the 27 come from? That's 3 to the power of 3 is equal to 3 times 3 times 3 is equal to 3 times 9, which is the same thing as 27. Okay, the last law, probably one of the more confusing looking ones, is x to the m, x over y to the m, sorry. So this is equal to x to the m, y to the m. As long as y is not equal to 0, this works. So very similar to the last law, an exponent outside of brackets applies to each part. Let's try that again. An exponent outside brackets applies to each part of a fraction within the brackets. A few examples that we did in class. We looked at something starting with 1/4 squared was equal to 1 squared over 4 squared, or more simply, 1 over 16. The other examples in class are here. You can pause it and look at them if you need to, if you miss them.